You know, some of them require that you put placeholders in. You probably, I hope that I gave you one, maybe two problems like that on homework. This needs a placeholder. This one here needed a placeholder as well. This took a while, and there's one with remainder. Interesting, this morning my grandson, he's a 6th grader. He didn't have anything with the variables, but he did have something where he was solving algebra equations. So they got him solving equations that look like this. This is the 6th grader. I think it was something like, let's say it was 2, x is equal to 5 or something like that. Let's say it was 2x equals 5, and he knew that to undo multiplication, you divide. So he knew that the answer to this was 5 over 2. But then he asked the question, how do you write that? And what he was interpreting is a mixed number. How do you, because there's a remainder, he kept saying, because it doesn't go in evenly, there's a remainder. So he knew the remainder language. And so I had to guide him today to say it's 2 with a remainder of, there's a remainder of 1. And then the denominator, that's what you're learning, is the, that's what with the divisor. He didn't know what the divisor word was, so I had to throw that out. The denominator. So the fraction part, denominator over here is the denominator over there. So that was this morning at 7 o'clock this morning to wrap up a homework problem or two before I went to school. See, this is your denominator right here. When it says take that and divide it by, see right here, this would be what x subtract 2. So yours is much more challenging, but it's the same concept. Remainder down here divided by the denominator, which was this right here. Okay, so I'm glad that some of you shook your head like you got some of them done, or maybe all of them done. So you're keeping up with the material. That's a good thing. All right, so here's 2.5, and I'm gonna see how many problems I got to do with you. 5, 6, maybe 7 problems today, looks like. I might skip one of them or 2 of them and have Bonnie, depending on time, have Bonnie work with you. I don't have a little quiz on for you today. There's no little daily quiz scheduled for today. So we'll go as far as I can in terms of the time we got. And of course, you'll join Bonnie afterwards. So here we go. Okay, so let's see. This is a polynomial of degree 4 right here. Degree 4. Let's see. Okay, all the terms in descending order of powers there. They're all there. You see this right here? That's the same thing as this. This actually factors or was found by the product of these two. They call them quadratic factors because they're degree 2 instead of linear factors. That's a degree 1. Quadratic factors have a degree 2 polynomial. So I'm not asking you to factor something like that. I'm not asking you to do that. I won't. You don't need to. The point is, how many answers, zeros, are we going to be looking for? You're going to be looking for 4. The degree tells you how many answers I need to have. I want them exact too. So if I'm looking for 4, and if you believe that this really is the same as that, I mean, you can FOIL it or distribute it and find out it is, but it's true. And if you set this equal to 0 over here, this says how many zeros or how many answers? I have 4. 2 come from here and 2 come from there. And I think you can see that the 2 come from here are easy 2 answers. 2 and -2. So there's 2 answers here. The answers here would have to be quadratic formula. So to find the zeros, you're going to set each factor equal to 0 and solve. So you'd have, x squared subtract 4 set equal to 0. Difference of squares, if you want to do it that way, just to make sure you knew. And there is another way of doing it as well. What, x plus 2. So the answer to this is x is 2. The answer to this is x is negative 2. Okay, this one here, you've got x squared subtract 3x plus 1, set equal to 0. Of course, a equals 1, b equals negative 3, c equals 1. So quadratic formula indicates that you'll take the opposite of b, the opposite of negative 3, oh, that's funny. Yeah, so that's should be all familiar. That's not hard stuff for you guys. So the hard stuff, or what you're going to learn today, is if you start off with this and you're asked to solve, that means you set it equal to 0, and then you graph. So that's step 1 is graph, and then find the, I call them nice x-intercepts. Now there might be 4 x-intercepts. There might be. You don't know until you graph it. There might be 4 x-intercepts. So you find the nice ones, and ideally there's going to be 2 nice ones. Because then I'm going to show you how to find the other, these are not nice. These guys are not nice. So here, there's 4 x-intercepts. If these were imaginary, this would have to be some negative right there. And then you'd only have 2 intercepts, and then the other 2 answers are imaginary because you don't, to have them all real, they all have to be x-intercepts. So no imaginary here, all x-intercepts. You'll find the nice x-intercepts, which turns out to be, for this problem, x equals 2 and x equals negative 2. You graph it, you'll find that out. And then what you'll do is you'll take the solutions and rewrite those in factor form. It'll look like this. So that's just subtracting 2 from both sides, and over here, same thing. And what you're going to do is you're going to do long division. There's a couple different methods, but long division, one at a time, that'll work. One at a time into this dividend. And your remainder should be 0 every time because you're a solution. The remainder will be 0. And if it's not 0, then you made a careless mistake somewhere. It has to be 0. If you did a one at a time, so I'll say 2 long division. And like you say, well, which one's first? It doesn't matter. So if you did it one at a time, let's say you did this one first, you'll get this down to a degree 3 polynomial as your quotient. Then this is the next one you want to do, but you want to do it not on the original. You want to do it on the result, the degree 3 polynomial. I'll say it again. You pick one of these, doesn't matter which one. Let's say pick this one. And you do long division. The result will be a degree 3. Then start it all over again with the degree 3 polynomial with that as your divisor. And then you'll get it down to the degree 2 polynomial. And then use quadratic. Degree 2 polynomial should be here. That should be the result. and then use quadratic formula like I did right there. Another way is if you have two answers like this, it'll speed up the process if you end up taking the product. Okay, I can pull that away. If you knew that x minus 2 is a factor and x plus 2 is a factor, if you take the product of these two, it's still equal to 0. And then you get x squared subtract 4 is still equal to 0. So you could use this as your divisor, which is what I'm going to do. It just shortens the step to the answer by 1. Because if I take this degree 4 polynomial here and divide it by the degree 2 polynomial, you'll be left with the degree 2 polynomial at the end quickly. So that's the way I'm going to do it. And look at the original. It looks like okay, to match this up, so that's going to be an x squared. Multiply here, let's see, negative 4x squared. So don't put it there, put it over here. Negative 4x squared, just line it up. That's what I do. Subtract, gone. You bring this down, so that's negative 3x cubed. That's positive x squared plus 12x. Subtract 4, and you continue the process. Meaning, I want to match this up with that. Let's see. Negative 3 and an x. Negative 3 and an x. So that's negative 3x cubed. And here that's, what, 12x. Put it over here. Okay, both of these go away. And finally, a 1, plus a 1. And there you have it. This remainder is going to be 0. And there's your leftover. And you do the quadratic form, which I've already done, to find your last two answers. Sure, it doesn't feel like usually most students would say at this stage, pretty mechanical again. It's not going to be challenging, hard. The challenging section's coming up in 2.6. Now that's a big section, but it's this right here, fortunately for you guys, I would think, the weekend's not going to be too difficult. I don't know how many problems I assigned you, but it'll probably be enough to get the feel for what's going on. Now, your author, there is some places in the textbook that he addresses that I don't cover. And some of you in high school may have covered it. It's called Descartes' rule of signs. Descartes, Rene Descartes, a mathematician, a long time ago. And let's see, the rational root theorem is another one that I remember teaching 100 years ago in high school. And then synthetic division. I don't know, anybody here done synthetic division? There's Devin, you remember doing synthetic division at all? No? Rochelle? No? Farbod? Synthetic, yeah. So, you know, synthetic division works nicely with linear factors, doesn't work good with quadratic, which is what I just did. So I'm not doing synthetic, I'm not doing Descartes. I'll kind of point it out to you in the textbook, what I'm not doing. You can even see factor theorems. Yeah, I'm not doing it. Remainder theorems, not doing it. I think this is 2.4. Oh, that's just division, long division. Okay, 2.5. What am I doing here? 2.5. Rational zero, sometimes we called it roots a long time ago. Roots are the same as zeros. Rational zero theorem, yeah, not doing it. Don't need to worry about all that. Oh my gosh, what's happening right here? Nope, not doing it. Nope, not doing it, not doing it. Don't worry about it. Nope. Sorry for the fuzziness. Yep, nope, not doing it. Use rational, nope, 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 nope. See, this question right here, I would ask you, find all the zeros of the polynomial function. So there's 3 of them. But I'm not doing the rational root theorem nor the Descartes rule of signs that you would have seen probably in 2.4 if you took a look at your textbook. I don't even address those 2 things in my packet, but the textbook does. So at the end, what do we got here? Okay, at the end, there they are right there. Well, that's nice. How are you going to find those? Calculator. That's not hard. So on the test, would I give you one where all your answers come out of the calculator by just pressing buttons? No, probably wouldn't. Now let's see what they do here. Oh, here's another one. Find all the zeros of a degree 3. So there's 3 answers. Could I have all 3 of them to be imaginary? Nope. Nope. You know, I don't know. I have a Math 27 class. We've already done this stuff with the Math 27. We're already starting trig because they took the monster class. They get the whole book in one semester. You guys don't. So the let's see what I'm going to say. I forgot what I was going to say. I have no idea what I was. That happens at my age. Anyway, degree 3, 3 solutions, and you're not going to get all the answers from your calculator. No, you're going to have to do long division somewhere. I'm going to look to see what the answers on this one. Aha, okay. So look at this. Okay, the answers are, there's 3 of them. Oh, that was my question. And now I remembered. Is it possible to have all 3 imaginary? That's impossible. So that's what I was going to say. I told my Math 27 it's impossible because imaginary numbers come in pairs, conjugate pairs. You can't have just one imaginary number without having a second one. So to have an odd number of answers and all of them be imaginary, impossible. Now they could all be real, which these are. Look at these are all real answers right here. One nice one, 2 whacked out ones. If I can find a nice one and then use long division. Now let's see, their method, oops here. Their method is synthetic division. All this kind of crazy stuff is synthetic division. We're not doing that. We're doing long division. So this is a good problem that I would ask. You know, I would give you this on the test. You'd find -3 being the answer. Then you're going to use long division to find the rest of them. So let's see what happens here. I'm going to use my calculator in this one. As long as I haven't made a mistake typing it in, looks okay. Zoom 6. There's an answer. There. All I need is one of them. I'll see what that one looks like. If it's some weird decimal, my method's not going to work. And so it only works if it's a nice answer. Second calc 0 appears to be, I can go like -6 and 6. -0.2. I can do this one because that's a terminating decimal. So this one here has x equals negative 0.2. Now, my suggestion is avoid the decimals. My suggestion is start off with make it into a fraction. So that's x equals negative 2/10. Then I would reduce. Now, my suggestion would be the following. I would rather not, and I'm going to avoid it, do long division with fractions. It's easy to make a mistake. It's messy. So here's the technique. I'm going to not make this a fraction by multiplying through by the LCD. I'm going to multiply through by the LCD, which is 5. And set that equal to, oops, sorry, got ahead of myself. Actually, that's even wrong. And then set it equal to 0, so I'm going to push the -1 over to the left-hand side. So my factor looks a little different than previous ones yesterday. And why it's different is because there's not a numerical coefficient of 1 here. So I'll deal with the 5, which, look at, that's going to be convenient with this. That's good. So I know that this is one of the answers. And now I'm going to use 5x plus 1 into and here we go. I need a 1x squared. And don't forget, multiply here, that's x squared, line it up. Subtract both, gone. Negative 10x squared, convenient. Convenient, it's a multiple of 5. And bring the rest down, 28x plus 6. Okay, multiply by -2. Don't forget the extra x. Negative 10x squared and minus 2x. On. You distribute the negative to -2 and add straight down. So 30x plus 6, convenient. And finally, it looks like a plus 6. Oh, remember I said the remainder has to be 0. Has to be. If this is an answer, that has to be 0 every time. And if it's not, you made a mistake possibly through here, or could have made a mistake up here to begin with. Like if I brought that negative over and made it a negative, then there would be a remainder. So you have to find your mistake. So then you go x squared, subtract 2x plus 6, set that equal to 0, and use quadratic formula on this. Okay, so this is going to have an imaginary number, actually 2 of them. So this is 2 over 2 plus minus square root of negative 20 over 2. So x equals 1 plus or minus. There's an I, but I'm going to stick it on the right-hand side. Just a reminder, complex numbers back in 2.1 has to be, for me, in A plus BI form. So the I is at the end. For your test, I get the answers from a test bank. The author answers could have the I in front. You just have to kind of recognize that. And 20 has a perfect square. That's 4 times 5. So it'll be 2 root 5 all over 2 with an I. So finally, x equals 1 plus or minus square root of 5 I. And there's your other 2 answers. So answers 2, answers 1, there's your 3 answers. That's a good one that I mean, if I could choose anything on my test bank, that's a real good one because it forces you to do a couple things. One is you've got to find the answer using your technology. And then here's a technique that I'm showing you. You don't have to do it that way. You could have easily dealt with the decimal and went plus 0.2. And then what would you do? To make the 5x cubed, you multiply by 5. But 5 times 0.2 is 1. So, I mean, numbers will come out nice. It's just I'm trying to avoid the decimal and or the fractions. Now this one here is another 3 answers. So I'll graph this right here. Okay, there's 3 answers. They're all real, no imaginary. So let's see, kind of looks, don't make assumptions. I'm going to say this again. If you make assumptions, that looks like a nice answer. That looks like -5, Jeff. It may be -5 1/4. It might be -5.25. So don't make assumptions until you figure it out like this. So -7, maybe -4. Oh, no, okay, that's a good answer, nice answer. You'd write this down. Okay, this one is x equals -5. Okay, how about this one? Kind of looks like -3, but don't make assumptions. Crap technology, very pixely. Could be off a little bit. -1. Oh, -3. Oh, that's nice. And shoot, I wonder if you get them all for free. I wonder if you get them all for free. Second calc 0. Oh, you got them all for free. There's probably a couple homework problems. You just do that and you get them all for free. There's no work except typing in your equation in the calculator.
Jeff, can we get that information from the table as well?
So, good idea. Could have bypassed all the extra pressing the buttons, and if you have set up your table, which probably all of you have, where it jumps by increments of 1. Here, I'll show you. If your calculator is already set up where it jumps, maybe you didn't know what I did, but it jumps by increments of 1. That little triangle means delta. It's a Greek letter of the alphabet. And in a calculus class, you may learn, depending on the instructor, what delta means in calculus. Bonnie, do you, Tom Falbo, or whoever your instructor right now talks about delta?
We definitely talked about it last semester, but we haven't gotten into it this semester yet.
Okay, so depending on the instructor and how they use it, they'll explain what that means mathematically. But right now, for you, it just means incrementally changed by 1. So if you've got that set up, oh, there's 2 of them right there. That's what, I don't know if it was Farbot or somebody had said, could you use this? Sure, why not? There's 2 of them. You kind of keep scrolling through. Nope, nothing else over there. Supposed to be 3 of them. There's 2. Oh, there's the other one. Hey, done. Yeah, just use your table, no problem.
Hey, Jeff, could you quickly show us how you got to the table setup?
Yes. You can tell the calculator where you want to start your table, but I don't know if it makes a difference, because then after you do a table, you can scroll up or down. Make sure that's a 1 is what I would do. And definitely make sure that these are both under auto. Auto. Yeah, I don't do the ask ever. Bonnie, I think I'll have you do this one today.
Sounds good.
There's supposed to be 5 of them. You could, oh, I got the garbage man going right by me. Loud, I can't hear. Of course, she'll stop right in front of my house for a moment. Okay. You could, there's lots of different ways of doing this one, Bonnie, but this is a good one to talk about and let you kind of work with them on this. Okay, I said to watch out for this one. This one's interesting. Let's see why. I can't remember why. Why? Should be 4 answers. Working over here. Oh, well, it could be there's no x-intercept. It could be. Now, there's supposed to be 4 answers. They could all of them be imaginary. Could be. But just because I went zoom standard doesn't mean that there aren't any x-intercepts. They could be outside the viewing screen. So I'm going to just stretch my viewing screen out a little bit, maybe out to 40 on either side. Maybe I'll start with 20, either side. Window here, and go -20 and 20, and see if there's anything in between -10 and 20, or -20 and -10, 10 and 20. Just see if anything happens. Yeah, it doesn't appear. It doesn't feel like there's going to be any x-intercepts. The only way you can do it my method, which I wouldn't give you anything like this on the test, by the way, because this would require having some knowledge about, hey, they're all imaginary. Now what, Jeff? I'm going to show you an example of now what in a moment. But you can't do anything with this. You need a nice x-intercept with long division. You actually need 2 of them. So I'm going to say, watch out for this one. You can't do it. Oh, yeah, let's see if that's the same one. Nope, different one. Okay, so a different one. Apparently, if I graph this, let's see what happens here. Let's see what happens. 4 answers. Let's see. Okay, well, they're not all imaginary. That's what I'm getting out of this. There are x-intercepts, but they're not all imaginary. And let's see what happens if I go, oh, zoom standard. I should do that, zoom standard. That's better. Oh, maybe there's a nice answer right there. Here comes garbage man again. I'm going to try to find the one on the right-hand side. Oh, one. Nice. I can do it. I can do it, and as long as I got a nice one over here too. Okay, and that's okay too. Negative 0.5, and then you can use the technique that I gave you with that very first one today. But I'm going to approach this one differently, because it could be that the two x-intercepts we found to be nice could be that the two x-intercepts are not nice. They're weird decimals. So if they're weird decimals, the only way you can proceed with the problem is if I give you some fact that one of the answers is that. One of the answers is that. So I'm going to approach it this way. One of the answers is this, use this somehow, and then eventually get to the place where x equals 1 and x equals negative a half. Eventually, not yet. I want to get down to that using this. So if you're given an imaginary number, you also know for a fact that its conjugate is also a solution. And what's the conjugate of 2i? Negative 2i. Here, little think bubble here. What if x was equal to negative 1 plus 2i? What's the conjugate of that? Okay, it's just change the b. Some of you are going to change both of them. That's not correct. The conjugate is keep that one, but change that one. Okay, that's the idea about conjugate. Here, it's the opposite of b, like that. Then I'm going to push these to the left-hand side, like I did our very first problem. X plus 2i, set that equal to 0. X, that should be minus, my mistake. This one is a plus. And since there's two answers, life will be a lot easier if you do it the method that I did the very first problem. The very first problem today, I suggested, hey, if you've got two nice answers, you could push them together. Where's my problem? Oh, here it is. You can push them together as the product and take care of long division all in the same step. Because if you don't, you're going to have to deal with, and it gets really screwy, you're going to have to deal with the I. I don't recommend that. So what I'm going to do is push these together. Foil. And you'll end up with x squared plus 4. You will at the end when you do that. Remember negative 4i squared and I squared is negative 1. I'll say it again. If you do the last term right here, negative 2 times 2 is negative 4. I times I is I squared. I squared is negative 1. So it's negative 4 times negative 1 is positive 4. And now I'll use long division on with this on that. So quadratic formula will always work. Sometimes it could factor. Remember my answers up here, right here, nice. So it does factor, it will factor, but you wouldn't know that. So I would probably, if I were in your place, just go right to the quadratic formula. But I'll show you what the factor pieces look like though. This one here would be a 2 and an x, and then it'd be an x and 1. Let's see, to get a negative x, this would have to be a negative here, and that's a positive right there. And you set that equal to 0, and you will get these guys. Set that equal to 0. See, there's the 1, and this become negative 1/2. So your 4 answers are these guys. All right, now if you're given all the zeros, so over here it says, I give you the function, find all the zeros. So going backwards, if I give you the zeros, can you create the function? See, creating the function, this one here, would be taking all the zeros, say f of x, taking all those zeros, writing them as factors, like this. And they're all your factors. This one actually could be a 2x plus 1 would be a factor as well instead of x plus 1/2. So over here it says, hey, I'm going to give you all 3 answers. Can you create a polynomial? It's just going backwards. So you would set all of these equal to 0 and multiply the factors together, and then write it in descending order of power, and you're done. So this one here, let's say I want to do f of x. Okay, factors, this would have to be x plus 2 equals 0. X subtract 1 is equal to 0. So and now you just go about your business, beginning algebra kind of concepts. I'll decide to take the x and give it to the first thing and wait on this. Wait. And then FOIL. Let's see. Something's not right. Oh, no, this is right. X cubed minus x squared, 2x squared. Yeah, this looks okay. So x cubed plus x squared, subtract 2x. Okay, there you go. There's the polynomial of degree 3. Find a polynomial of degree 3. There you go. Could this be another function? So let's say it's g of x. Well, could that be another, well, it's another function, but could it be another function that satisfies this, the case that all of these are still answers? Well, I don't know. Let's try. I'm gonna check this one out first to make sure I get all of these answers, and then I'll check this one and see if I get the same answers. That's all I want, is a function that gives me the answers. Maybe there's more than one answer, more than one function. I'm going to put this one in first. Well, it looks like 0, which it will be 0. Looks like 1, which it will be, and looks like -2. If you check them out, it'll work. Okay, you don't believe me. I'm going to check the left one out. Second, 0, -6, -1. See, -2. There it is, -2. I wanted x to be -2. So I'm going to put this one in now and see if I get the same 3 answers. The picture looks different, but I'm looking for the x-intercepts. Okay, you don't believe me. I'm going to check that one. Is that -2? I don't know. Let's try it. -5 and 0. Oh, well, there's one of the answers. 0. I meant to get -2, so let's try it again. -5 and -1. Oh yeah, -2. So the thing is, you can have infinitely many functions. The numerical coefficient of the leading term could be any number you want. You just have to remember to multiply it through all of it. All of them had to be multiplied by -2 to get a function that satisfies the 0 conditions. Okay, and the last problem that I'm going to do is this one, and it's got this thing about multiplicity. So if it's multiplicity 2, you would have x equals 1 and x equals 1, and over here you've got, let's see, x equals 0, degree 5. Okay, 1, 2, 3 answers. So here's 4 answers. And gosh, I need a 5th answer. I got 4 of them. 1, 2, 3, 4. 5th answer, what's that going to be, anybody? What's my 5th answer going to be?
1 plus I.
Yes. So it's the conjugate. Ooh, okay, this is going to take some time. I'm going to have Bonnie kind of work this one out with you. Here's the key, Bonnie. I want to make sure that you see this. I know you'll be able to do this, Bonnie, but this one here, if you're going to set it equal to 0, you're going to have x subtract 1 plus I equal to 0. And x subtract 1 subtract I equals 0. And Bonnie, I'm going to suggest that you work with these two first. And it's not FOIL like a binomial, but they're 3 terms. It's messy, but when you're done, it'll come out really nice, Bonnie. And there's not going to be any I. If you do it correctly, there won't be any I left over. And then you still got all this other stuff. It's going to take at least a half a page, maybe a page of work. So if anybody wants to see this done, Bonnie, you can do it. If nobody wants to see it done, then I'll leave it up to you whether you want to do it or not.
Okay.
So Bonnie will go through this with you today if you want. She'll also handle this one somehow today. And if there's anything else that you have questions for her, like some homework problems, I'm sure she'll do her best. Like me, I'll do my best to answer any questions. So let's see. So any questions of me for me today? Looks like it's 10 o'clock, which is good timing. That's about an hour of my time. I'll stick around after class asks, to answer any personal questions or one-on-one. Otherwise, Bonnie's going to head off to her Zoom class. I'm going to give you a heads up also for our class next Tuesday. I'll say be looking for it sometime today. There's going to be an email, sent out to you with an attachment that describes what I'm going to verbally tell you right now. Next Tuesday, I won't be live. I won't be live like this. So what's going to happen? You go see Bonnie like you typically, some of you have, half hour before class on Tuesday. And then afterwards, usually you come here, but you won't come here. The next section has already been uploaded as a video to you. You just don't know where it is. I'm going to show you right now. And my instructions in my email today, my attachment, will also indicate the same thing. So you're going to watch my recording. I have recorded 2.6 for you. I'm not going to be around on Tuesday. But that doesn't mean class is canceled. It just means you're going to do it differently. So go see Bonnie. And then my video, if you wanted to watch it already, it's there on 2.6. And then you can watch it again if you want, multiple times. And I'm going to show you where it's located. Okay, there you go. Devin, can you see this says learn more and everything? Can you see this page? Okay. Let's see my inbox. Dashboard. I'm going to go in as a student somewhere. Let's see. So my instructions will tell you the following. It'll say, go into Pages. I've just activated this thing called Pages. Go into Pages, click. Then my instructions will say the next thing is click on View All Pages. Click. And here it is, 2.6. There's two parts, 2.6 part 1, 2.6 part 2. It's a pretty decent size section. So I have two parts. So I would do part 1 first and then do part 2. If you click on part 1, look at, I even done 3.1 for you just for the heck of it. If I do 2.6 here, click on that. Little video, so click on that. I don't know, can you see, Devin, this video coming up? Okay, it's a YouTube.
Well, you're watching me on a recording for 2.6, Math 25 2.6, on rational functions. And the numerator is smaller right here.
So I've done all of it, except it just won't be live. You're going to watch two parts, two videos. This one's 41 minutes. Let's see where the other one is. Let's see, page. View all pages. I don't know what this one is. Let's see. 41 plus 23. Oh, okay, that's an hour. There you go. You got an hour's worth of me doing it ahead of time. So they're active and you can watch it right now or the weekend. So during that time, you know, that, what is it? We meet usually 9, right? 9 to 10:30. So 9 to 10, I've dedicated, you know, in theory, our class time. And then Bonnie will be in her session afterwards. So from 10 to whenever she's done, she will be available to answer any questions for you anyway, no matter what. So Bonnie's window of time has not changed, won't change on, is that right, Bonnie? We talked about this?
Yeah, I was thinking 10:15, but that's fine.
Oh, 10:15 is fine too. 10:15, there you go. You got word. And she has, and if anybody, do a chat right now, if anybody needs her Zoom sessions, ask her for it right now and she'll send it to you. Because
It's
I won't
on
be
the
around.
assignments page, or announcements, sorry, for our Canvas homepage for this class. It's on the announcements tab, so you can find it easily on Canvas there.
Great. So that's Tuesday. Tuesday, I will not be physically in class, but you'll see me on YouTube. Okay, any questions before you guys take off?
I had a question. I know you said that example number 2, that you were going to have Bonnie work out if we wanted. Would that type of question be on one of our exams or our quizzes? Okay, thank you.
Any other questions? Okay, I'll stick around. Anybody wants to stick around with me, fine. Otherwise, I'll see you next week. Sounds like Thursday. All right, take care. Sarah, do you have a question for me?
No, I didn't. I was just slow in closing it.
Okay, no problem. Okay.